All right, so today we're going to look at the different types of rain formation and emergency preparedness for meteorological weather, dangerous weather that can happen, that can occur. So first things first, this is the last lesson before your test, which is going to be on Wednesday. Again, extra credit is due by Wednesday. We're going to have a review tomorrow. And so last lesson. Pay attention, take notes. You are definitely going to have to take paper notes at the end of this. I have some stuff to add that is not on the doc that I send you. So rain formation. All rain forms by the following basic principles. We saw this in the lab, the dew-point relative humidity lab. As the warm moist air rises, we've talked about this before, it rises, and because it's warm, the molecules want to move around. They move a lot, and as they rise, they get farther apart, and they start to lose that energy. When they lose the energy, it starts to slow down, starts to get colder, and then it's going to hit dew point temperature. Dew point temperature is where water vapor then turns back into a liquid, which condenses. It has to condense onto something, and in this case the nuclei, remember, like the dust or something of that sort, volcanic ash, any of the particles that are in the air, it can condense onto, and the more there are, the smaller the rain, the less they are, the bigger the raindrops or snow. This water will then precipitation. It will come back down to earth as either a solid or a liquid. You've got snow, you've got rain, or you've got all the stuff in between, like the slushing and the little like snowballs and the sleet, all of it. These processes occur in different parts of the world, creating different types of rainfall. You have three types of rainfall we're going to talk about. The first one we're going to talk about is called orographic rainfall. This is common on the west coast of North America. I think that's where you have all those big mountains, and then the ocean's on one side, and then you have deserts on the other. Well, this is because one side of the mountain gets all the very, very wet, and the other side is very, very dry. Think of like Holes. If you watch the movie Holes with Shia LaBeouf when he was a lot younger, where they were sent to work is very, very dry, but on the other side of the mountains it's very green and lush. Why is that? Well, you have the two different sides, the windward side, the leeward side. So all this warm, moist air that comes off the water rises up, and remember, as warm air rises, it starts to cool, and then it condenses onto condensates, the nuclei, and then it rains back down. And so on this side, moist air is forced up, and it cools, and then it creates precipitation, which comes back down, and then it goes over, and on the other side, the leeward side, you remember those back from the weather and erosion? Windward side, leeward side of the sand dunes, very, very similar. And so on the leeward side, or the rain shadow side, it receives very little rain. And that's where you get your desert. Okay, so now you have something called the convectional rainfall. We did see these before, and these happen at the different, it should be degrees, not 300, 600, 900. These are at the 30 degrees north, 60 degrees north, 90 degrees north, and south. You have the convections found year-round in regions, and they experience, so where there's low pressures, right here about the 60, they get lousy, with partial sunny. Not as bad, but it's kind of rainy, dreary-ish. Think of, if you've ever heard about Ireland, it's very, very wet and rainy. Think of like Washington, D.C., not Washington, D.C., but like Washington, the state. Forks, Washington, you've seen it in Twilight, very, very rainy. Seattle, very, very rainy. That's this. And then at highs, it's nice and bright and sunny. And then you've got another low right here. It's kind of rainy. That's where you're going to find like the rainforests. And then here's your high and sunny. So how you can remember this is high C. Highs are happy. High C, think of all this. highs are happy, lows are lousy with rain. High pressure areas experience little rainfall, low has lots of rain. And then you have these, you've seen these before, the frontal rainfall. When different air masses make contact at an abrupt zone, and it forms a boundary called a front, and it's accompanied by abrupt changes in temperature, humidity, and pressure. Now this one right here you see is red. Red is warm. So warm fronts, where the warm is pushing out the cold, and it's characterized by several days of rain. So it's a lot of rain, and what comes after is colder than the weather that was before it. And then you have this stuff down here, the cold front, where the cold pushes up the warm air and pushes it out of the way. And as it does that, because as warm air rises, it cools and it creates precipitation. That is why it happens fast. It's fast front that comes through. It's heavy, brief rainfalls. And then you have wind directions. You can just see these as we're going, as we're revolving. You can see like different sections of the world have different wind directions. Like the Hadley cell, it goes counterclockwise. The Ferrel cell is clockwise, and then the polar cell is counterclockwise. And you'll see that in the opposite. This is part of the sphere. And then when it comes to wind picking up, because low pressure, you're going to have air rising. Lows go counterclockwise. And highs, you know how I said high C? Highs go clockwise, where it takes all the high, nice, warm air and it pulls it down to the ground and pushes it out, which then goes to the lows and pulls it up and goes down. And you can see a kind of convection going around right here. All right, and last but not least, we have emergency preparedness. So what would you do if a tornado came? Because they do happen in New York State. They happen all over. So the first thing you want to do is you're going to want to stay away from the windows, because you're going to have very, very high winds picking up debris, and it can shatter those windows. And it's very dangerous. You don't want to get glass on you because it can cut you up, and that's not cool. So stay away from all windows. What else should you do? Well, if you have a storm cellar, a basement, something of that sort, you want to get down low and away from windows. What happens if you're outside? Well, let's go under a bridge. Actually, that's not good. What you want to go is in a ditch. Bridges are very, very dangerous because they make a wind tunnel which can suck you out, and that's not good. So you want to get as low down as you can into a ditch, as flat as you can. Make yourself as big as possible on the ground. Okay, well, what about hurricanes? They do happen, not so much around here, but if you go down lower, you could experience a hurricane. Well, with hurricanes, you want to go inland and as far away from the coast as you can go, because that gets you away from the swells from off the off the water. And when you're inland, it is not as potent because it doesn't have all that fuel to suck up. All right, so that is it for right now. If you have any questions, please get on Zoom, talk to me, let me know, email me, class tag me, and besides that, I hope you guys have a great day.